Alright, so today we are going to look at the first three problems of today's uh, weekly contest 405. The first problem states that find the encrypted string. It's a very straightforward problem. Basically, we are given a string and we need to change every character to the character which comes after three letters and after K letters, right? So this will change, this will be changed to P, and this is suppose a circular one. So every time we go out of index, we come back. So A will be replaced with D, and similarly R will be with A, P will be with R. This is how we can convert all the letters. Let's let's do that. We can have a string answer. So we are not changing this value because if we do it in place, then that would be a problem. Because we are going to be needing the letters that we have that will be changing, right? If we do it in place, that's not correct. Start length a plus plus. So answer plus equal to s of what? I plus 3 mod. I can take s dot length as a n variable, and this assigned value can be n, and this will be n. We return the answer. Let's see if this works. Straightforward. Time complexity will be O of n. The space will be O of 1. The space will be O of 1 because I don't count answer as the you know space, the extra space, because since we were asking string. The next problem states that it's called generate binary strings with adjacent zeros. So it states that integer n equal to 3 or any value is given, uh, and we are asked to generate all the possible uh, binary strings that we can generate, which has this condition, that is every length of 2 must contain at least one 1. So it cannot be 0 0, it cannot be a 0 0. It can be a 0 1. It has to be, this is valid, this can be the case, and this can be the case. So these three can be the only case. 0 0 is not valid. So we can straight do a brute force DFS using recursion. Basically, we have a streak count. And that streak, if we are taking 0, then we don't increase that streak, or we increase that streak. If we take 1, then we take the streak back to 0. So if we have, let me explain it here, this streak or whatever variable I would call it, I think streak is not a, yes, streak can be the variable, like streak means streak of zeros here. So if this is 1, right, then the next value uh, I have to take 1, right, because there's 1 0 already in the answer. So I have to take 1 here. There is only one scenario here, but if the streak is 2, not 2, it can never be 2, it is 0. Then I have two possible values. I can take 0 or I can take 1. Right? That is how we are going to solve this. Solve function, streak, end, and the current string. I will be returning I can have a vector of string actually. Don't need to return anything. and void solve. This is streak, this is int, this is current string, and I check if the uh, size of the current string is equal to n. In that case, I return. Before returning, I will add it to the answer. Current string, I will add it to the answer. If this tree is equal to 0, then I can have 0 or 1 both. So I'll have solve equal to this tree. So I choose 1. In that case, streak will go back to 0. It will remain 0, right? And I will add 1. Similarly, I will add 0 and I will increase the streak this time. If the streak is equal to 1, then I will have only one scenario, and that is this one, and I return. And that's it. Let's see if this works. Yeah, the time complexity is this is basically brute force. So I am having two choices at every point. N uh, n is the size, so every character is having two choices during some times, but is having one choice during other times. So basically, it's going to be O of, 2 to the power n, as far as I think. Could be wrong. I have to rethink. This is the third problem. Count submatrices with equal frequency of x and y. This is the example. Basically, we are given a submatrix and we are asked to include the submatrices, all the submatrices, which includes the first cell. So basically, we can include this, we can have this, we can have this, we can have this. Let me keep the pen. So what I was trying to tell is we should include this first cell. So this is a possible submatrix. This is a possible submatrix. This is a possible submatrix. Even this is another possible submatrix. So we have to include or count all the submatrices which have the x and y values equal in number and at least one x. So there can be dots as well, there can be only y's. So we have to include the submatrix which has at least one x and the count of x and y is equal. No matter dots, we are not caring about dots. So this is a straightforward prefix problem. We can have a prefix of x and y counts, and we can just uh, at the end from the prefix we can just keep adding because we don't have to subtract, right? During actually I don't need the comment. I can do it here. So if you have something like this, right, how do we calculate a prefix? So 1, 2, 3, 4, 5, 6, 7, 8, 9. Suppose this is the prefix. This will be what? 1, 3, 6, this will be 5, 12, this will be uh, 8 plus 5 minus 1. Right? 8 plus 5 minus 1 is 13 minus 1, 12. This will be 12. So if we try to calculate 6, 6, so the sum of this matrix is 12. So how did we find this 12? This is basically addition of this one, and subtraction of this one, right? Why this one is subtracted? Because we have 1 here as well. Since we added 1 to 2, that's why we have 1 contribution here as well. And we have a 1 contribution here as well. But we can only have 1 contribution here because we can't have 2 contributions. Right? At the end, we are getting 12, which is a sum of these, this, and this. So we have one only once. That's why what we do is we add 5, we add 3, and we subtract 1 so that we have only one copy of 1 inside 12. This is how we do prefix sum of 2D matrix. And the query that we will need is what? Suppose if we want only this, what is the sum of this submatrix from the prefix? How will we calculate? We can do that uh, by subtracting 12 minus uh, 5. Yeah, yeah, minus 5. That's it. So if we subtract this, what essentially we are subtracting from this? We're subtracting this, right? Isn't it? So what we will get is 12 minus 5 is 7, and 2 plus 5 is 7. That's how we find the query or sum of a particular matrix. And what we are asked is we need to find the entire submatrix which includes the first cell. So essentially we are trying to return this. We are not subtracting anything. We are subtracting zero zeros from it so that it will always include this first cell. This is the whole idea. Let's get into the code. We have a vector. I am coding this way, but there will be, easier codes that you can find over at Leetcode Solutions. But I do this way because it's easier to understand. It's a long code, but it's easier to understand at least. So this will be of size grade.size. Let me take the values actually. Int n is equal to grade.size. Int n is equal to grade 0.size, and that's it. This will be n. This will be n, and this will be vector of int. This is another size that I'm adding, that is 2. So for every submatrix, I'm having 2 cells. Inside one cell, I'm having 2 cells because I need counts of 2 every time I move forward in the submatrix, in the matrix, right? So I want x value and y value not. That's why size is 2 here. Alright, this is the whole thing prefix. I will assign the first value as what? 0, comma 0. Right. Essentially, I'm assigning prefix 00 with 0 counts. Yeah, and let me build the first row. So the first, I can have the first row and first column built separately so that I can later build the remaining prefix using the first row and the first column so that I don't have to worry about the base case. I know it's a little longer code, but it's fine because it's easier to understand. That's why I'm doing this way. Building the first row. First row will be using I, prefix of I, 0, first column, yeah, first row, and for 0, I'm going to have the value. Essentially, I don't need this. Let me have a value count 1, count 2, here I am checking the grade value equal to x. If it is, then I'll increase the count of 1, else I also should check for y because they can be dots. Our count of 2 will be increased by 1, and I'm going to add this to my prefix. Yeah, or I can do it like this. Count 2. Now I can just copy paste this for the first column as well. First column, I don't need to initialize this again. I can have n here, I can have j to be more precise. This will be 0, this will be j, this will be same as it is, this will be j, sorry, this will be 0, this will be j, and essentially this will be 0 and this will be j. So now I have the first in the first column. I will have the remaining matrix built here. Matrix, the prefix. This is like this. This is the second inner loop. Now I basically can have a count 1 as 0 and count 2 as 0 if the grid value of I and j, I should by the way start this with 1 because I have already built for the first in the first column, is x, then I have count 1 as 1, else if, let me copy paste this, we use some code, count 2 is equal to 1, and now prefix of I j 0 is equal to prefix of I minus 1 j plus prefix of I j minus 1 minus prefix of I minus 1 j minus 1 plus count 1. Similarly, for the next cell, count 2. This will be as it is. This will be 1. Now I have the prefix built. So just traverse basically have the same thing here. I have an answer. Right now, if prefix, or I can just take the pencil, something called count 1 is equal to prefix of I j 0. Similarly, count 2 will be here. So this is what count 1 is x count at whatever point we are at. This will start from 0 by the way. And count 2 is count of y. If count 1 is greater than equal to 1 and count 1 is equal to count 2, then we increase the answer by 1 and else we come out and we return. Let's see if this works. And alright, so this is going to be 0. This is going to be 0. Sorry, this is going to be 1. This is going to be here. This is going to be here. This is going to be here. This is 1. This is 1. Let's see if this works now. It does. The time complexity will be O of m cross n, and the space complexity will be O of m cross n. Uh, into J. Sorry, this will be rid of Ij. Let's see if this works. It does, and yeah, there might be some easier implementations as well. So you should check that out as well. Uh, yeah, thanks.